wherein the sensitizer or erudite is incorporated after spin coating the TiO2 onto the solar cell. And this is how it works. So similarly, we had the same mechanism as before. We just took out the electrolyte. So excite, inject, power the load, and regenerate. And this is what I got. Apparently, it's also not working. So I tried something else. So this is the final cell that I made, called the bulk heterojunction cell. Actually, Dr. Enriquez gave me this. How about, Douglas, why don't you try this? Why don't you try leaving your TiO2 conducting glass into a solution of sodium sulfide, then put it in another solution of iron chloride, and then wash it. Before that, then wash it. Unfortunately, that didn't work. What I did was that I only washed it after, and this is what I got. So here's the bulk heterojunction, similar setup as a while ago. Let's see what happens. So basically here, what's happening is that electrons from here, this is just imagine this as the erudite bulk heterojunction. The electrons produced by erudite, since it's an N-type, goes into the TiO2 and then follows a circuit similar to what you saw a while ago. So wow, for the first time we have a solar cell. Unfortunately, it's very, very small. That red line there indicates that yes, we indeed do have an iron sulfide solar cell. So here are my results. Here is the efficiency that I got, and unlike the first cell that I made, I arrived at twice what I originally had in terms of voltage. Here are my conclusions. So what did we want to do? We wanted to fabricate a working photovoltaic cell, be able to characterize its electronic properties. Done. Recommendations. Unfortunately, there are still a lot of things we need to do. I still need to characterize in terms of doing some imagery for SEM-EDX. While taking a photograph of my sample, we need to find out its composition so that we can beef up the XRD that was shown a while ago. Then we will be getting imagery from the AFM, the band gap calculation for my method of making erudite, and cycling voltammetry to find out the HOMO and LUMO of my cell. Here are my sources, and I don't have acknowledgements, but thank you to all the people in the thesis lab. They made life bearable. Thank you. That's right.
So all the three solar cells
Amazing.
Yes.
So you told us that 2 out of 3 didn't. So any initial
Okay.
sinabi ko lang rin.
Yeah. For the first one, we feel that we're not sure exactly of the bulk heterojunction solar cell. We're not exactly sure if there's an electrochemical process that's happening. So that's why I wanted to stay away from that, because finding out whether or not it was gonna work, because most of the time I spent doing my thesis was just adding surfactants, and that took a long time. This one I just did it 2 weeks ago in Evacell. So, but to answer your question, as indicated by Corgel already, we feel that that there is sulfur vacancies as well as surface defects. So there needs to be a way to still maintain erudite as it is without it turning into another morphology of iron sulfide, and at the same time reducing the grain boundaries, because that prevents the proper movement of electron in the cell. Any other questions? Oh, yeah, David.
We tried spraying your erudite. Let's say this person had in a solution, and then maybe using nitrogen as a carrier gas.
Okay, so initially I wanted to try that out, but I was too allured by the new machine upstairs, so I went for spin coating. So I wanted to give it a shot because the kinds of substrates that I'm able to make are really thick. And now what that does is that, well, of course, you have a reduced amount in terms of material cost. And what we're trying to do is that we're trying to make a thin film cell similar to copper indium gallium sulfide as well as copper sulfide based solar cells.
Hindi si Jeremy na.
Sorry, yes.
So what's that Schlenkline setup that you did?
What?
Schlenkline, whatever that is.
Okay, so actually it's a funny story. David saw when he was trying to apply for his doctorate, didn't also know what the Schlenkline does. So I'm in the same spot. So both of us wanted to make it oxygen free. So a Schlenkline, what it does is that you have a vacuum, and then while nitrogen is being introduced into the system, what you're trying to do is there's a molecular sieve which takes out the water out of your nitrogen, if there is any, and the oxygen, which is taken out by permanganate column. But this one, for what I did, it wasn't really necessary, and I didn't know what the Schlenkline was until Doc Epe told me.